Welcome, my dear students, in Prep 3. Let's continue our geometry lesson. We are in Unit 4. Today, our lesson about identifying the circle. A circle is identifying if we know its center and its radius. We can draw a circle if we know its center and its radius. Okay, today we will learn how to draw a circle passing through 1 point or 2 points or 3 points. First, I want to know how to draw a circle passing through a given point. If, for example, we have a point A and we want to draw a circle passes through point A. In this case, I'll choose any point in its plane to be the center of the circle. I don't have a radius, I don't have a center, so I'll assume any point in the plan to be the center, for example, point M. I want this circle to pass through point A, so point A should be on the circle. So I'll open my compass, the radius will be the length of MA. And I'll draw the circle. Another student can choose another center, for example, M dash. And by the same way, open the compass as the distance between M dash and A. So I have another circle. Or you may choose another center like M double dash. And then also open the compass as the distance between M double dash and the point A and draw another circle. So if you want to draw a circle which is passing through a point, you can draw an infinite number of circles. You don't have the center, you don't have a radius, so you can draw an infinite number of circles passing through one point. So you can draw an infinite number of circles passing through a given point. Okay. If the circles required to pass through A are congruent. What do I mean by congruent? It means that they have the same radius. If all the centers are congruent, in this case, the centers of the circles lies on a circle. Like here, this dotted circle, the centers AM1, M2, M3, and M4 are located on a circle. This circle is congruent to these circles. And the center is the point A. But this is a special case if all circles are congruent, have the same radius. What about if we have two given points and we want to draw a circle passing through the two given points? The first step, for example, if we have point A and point B and we want to draw a circle passing through the 2 points A and B. Okay, I'll draw the line segment AB and I'll draw the axis of symmetry of this line segment. The axis of symmetry, it means the perpendicular bisector. We studied before in Prep 1 how to draw an axis of symmetry of a line segment. Briefly, you can open your compass and open greater than half the length of AB. Put it in A and draw arc up, arc down. By the same open, put in B and draw another arc up and down, and then join the point of intersection of arcs. Okay, so now we have an axis of symmetry of the line segment AB. The center will be any point on this axis of symmetry. If you choose any point on this axis of symmetry, this point can be a center of the circle. So I'll choose, for example, point M here to be the center of my circle. Then I want the radius to draw a circle. I need the radius. Okay, so I want the circle to pass through A and B. So I'll open my compass from M to B or from M to A. They are equal. And then I'll draw this circle. For example, I'll open my compass as MA, the length of MA, then I'll draw a circle. So to draw a circle passing through 2 points, draw at first the axis of symmetry of the line segment AB, then choose any point on this axis of symmetry to be the center. Then you can open the compass a distance from M, the center you choose, to any point A or B, and then draw the circle. So we can draw infinite number of circles because we can choose infinite number of centers. Okay, here for example, if you choose M, you will draw a circle. If you choose M dash, another circle. If you choose M double dash, another circle. So we can draw infinite number of circles passing through the 2 points A and B by choosing another centers. If you know the radius, you don't know the center, but you know the radius. If A and B is a line segment and it's required to draw a circle passing through points A and B, if you have a radius greater than half the length of AB, if the radius greater than half the length of AB, in this case you can draw 2 circles, one of them up and one of them down. Okay, if R equals half AB, in this case we will only draw 1 circle, and this is the smallest circle you can draw passing through the 2 points A and B. In this case AB is the diameter of this circle, and of course the diameter is the greatest chord. So if R equals half AB, in this case you will draw the smallest circle which can be drawn passing through the 2 points A and B. But if R is less than half AB, in this case it's impossible to draw any circle. So any 2 circles don't intersect at more than 2 points. Any 2 circles can intersect in only 2 points. What about if you have 3 given points and you want to draw a circle passing through the 3 points? At first, if the 3 points are collinear, it means the 3 points on the same straight line. In this case, it's impossible to draw a circle passing through the 3 collinear points. But if the 3 points are non-collinear, if the 3 points non-collinear, in this case you can draw only 1 circle, a unique circle. How can we draw it? Let's see here. For example, we have A, B, and C 3 points, and I want to draw a circle passes through the 3 points A, B, and C. What should we do? We will join A with B at first, and B with C, or A with B and A with C. Now we have 2 line segments. I'll draw the axis of symmetry of AB and also the axis of symmetry of BC. The 2 axes of symmetry will intersect at a point. This point is the center of the circle. So this is point M. Now I want to draw a circle. I'll open my compass as the distance between MA or M and B or M and C. For example, here I'll choose the distance between M and B, and it's equal to MA equals to MC. Then I'll draw the circle. Now this is the unique circle passes through the 3 points A, B, and C. Okay, the circle which passes through the vertices of a triangle, like here, the triangle ABC, this circle is called circumcircle. The circle is called circumcircle of this triangle. And the triangle whose vertices lie on a circle is called the inscribed triangle. So we have circumcircle and inscribed triangle. The perpendicular bisectors of a sides of a triangle. For example, here L1 is a perpendicular bisector of AB, and L2 is the perpendicular bisector of the side CB, and by the same way AC L3 is the perpendicular bisector of the side AC. We said here the perpendicular bisectors of the side of triangle intersects at a point. Okay, this point is the center of circumference, circumcircle of the triangle. As you can notice, the perpendicular bisector is the axis of symmetry. So if we draw the axis of symmetry of each side of a triangle, the three axes of symmetry will intersect at a point. This point is the center of the circumcircle of this triangle. The position of the center of the circumcircle of a triangle, M for example, differs according to the type of a triangle as shown here. If the triangle is an acute angle triangle, in this case M will be inside the triangle. If it's a right angle triangle, in this case M is the midpoint of the hypotenuse. If it's an obtuse angle triangle, in this case M will be outside the triangle. We have a special case here. If the center of circumcircle is the center of the circumcircle, if the triangle is an equilateral triangle. In this case, this point, the center of the circumcircle, will be the same point of intersection of its side axes, and it's also the point of intersection of altitudes, the point of intersection of medians, also the point of intersection of the bisectors of the interior angles. Also, we notice that we can draw a circle passing through the vertices of a rectangle, square, or isosceles trapezium. Rectangle, square, or isosceles trapezium, but we can't draw a circle passing through a vertices of a parallelogram or a rhombus or a trapezium, which is not isosceles. We will discuss this point in Unit 5. Okay, that's all about our session today. I hope you practice more how to draw a circle passes through 1, 2, or 3 points. Thank you very much for watching. See you next session and goodbye.